Essentially today, well, I want to present a bit of a project called Milk Truck, where we employed, let's say, smart sensors to track quality parameters at the farm to help essentially farmers to get some control on, well, their herds. As already introduced by Boris, I'm Orangelo Petruzzella, currently the Managing Director of Multispectra. I will well introduce a bit. First of all, the problem that we were addressing, we're still addressing today, and it's this one. So essentially, currently, farmers do not have control on the quality of their cows and of the milk that is produced every day, and this is very essential to monitor properties directly after milking. And typically there is a quality control done at producers before reaching consumer, but they lack this kind of information today. And this is a kind of problem because essentially they don't have any way to check, for example, the health status of the cows. And if they had the opportunity to measure directly after milking, they would be able, for example, to prevent diseases and also to, again, improve the quality directly at farms. So within this project, we try to address this problem, and by the combination of a software plus hardware infrastructure. So this project actually, well, included two parties, Multispectra, that is a spin-off from Eindhoven University of Technology, and is actually commercializing a tiny spectral sensor that you can see here for non-invasive testing, and this sensor is based on near-infrared spectroscopy. Here you see essentially the sensor already integrated in handheld device and also in a fiber device for both solids and liquid analysis. And let's say the main advantage of this sensor is that essentially is the only and the unique solution on the market that essentially enables a full integration of, let's say, a 1 meter large instrument, a very expensive instrument, into a tiny chip without, let's say, requiring any moving elements and essentially having the full power of a laboratory into a chip. And also enabling a fast and robust measurements. And well, we have been collaborating with AgriTruck, that is a Greek startup company focusing on food processing automation, and currently commercializing a platform for IoT and based on an immutable ledge. And essentially, AgriTruck is currently well, helping food companies to reduce food losses and cost, and also enabling, let's say, a traceability system from farm to fork. And they were already using sensors to, let's say, automatize many processes from at farms. And they're already involved, for example, with 200 milk farms in Greece that are daily producing 35 tons. And at that time, so one year ago, there was still not, they were looking at solutions, let's say, to measure these properties at farms, and well, there are no sensors that can do that in the market right now, right? Because as I mentioned, typically these instruments are very large, very prone to shocks and vibration that are used in a laboratory environment. So we essentially started working on this project, defining a few milestones as usual in a work plan to, first of all, let's say, have a module, a spectral module that you can see here that we call SpectraPod, that has essentially a cuvette system to measure directly milk and to characterize this module from an electrical and optical perspective, and then working towards a data and a software integration with the AgriTruck platform to integrate this spectral data into their software system. And as you can see here, we actually have done, first of all, let's say, calibration of our sensor in Greece with, let's say, samples that were collected directly from farms. And we are actually talking about 767 sheep milk samples. As you can see here, these are actually the results that we got from the characterization of the sample. So there was quite a lot of efforts to measure all the samples, and in particular to build a machine learning models that connects the raw data from the sample to, let's say, the fat and protein content of the milk. And these are actually the main parameters of interest for this specific application. So as you can see here, this is actually already, let's say, the raw data and how, let's say, the distribution of fat looks like in these samples. And we were able to, let's say, build successfully a model for fat prediction still based on this sensor. Again, this was done directly from samples collected from a farm. And as you can see here, we were able to predict pretty well the fat content without using any, let's say, standard laboratory equipment, without using any destructive method. At the same time, we also tried to develop a model for protein estimation. These again are all the raw data. And also here we were able to build a prediction model that works pretty well. It is less accurate than the fat one, but as you can see, we can have, let's say, a relatively rough estimation of the protein percentage on a given data set. So in the end, essentially, we performed the full calibration on the sensor, and also at the moment, essentially, the sensor is still being employed in 2 farms, and this brings me to, let's say, conclusion. Essentially, we were able to demonstrate that using, let's say, our spectral sensing technology that was developed over the last 6 years in Eindhoven, we use this technology to validate a specific application case for milk testing on a relatively large data set, showing, let's say, promising results for fat and protein content estimation directly at farms, and validating this experiment using external laboratories. At the moment, we are employing several units of this sensor at farm level, and as a next step, we are working, let's say, on a more ruggedized version of the sensor, which can be also, for example, be connected to a smartphone to further be deployed in the major farms in Greece. So this concludes my presentation. And again, thanks for your attention. In case you have any question, you can reach out directly via mail, in particular if you are interested to, to have some, get some feedback on